Welcome to the deep dive. Today we're pulling back the lid on something you probably walk over every day, but maybe don't think much about, the humble manhole.
Right. They seem simple, but they're absolutely critical gateways.
Exactly. Gateways to our underground lifelines, wastewater, stormwater
Is
systems.
that-
Keeping them working, it's actually a surprisingly big engineering challenge.
It really is.
So our mission today is a deep dive into this really comprehensive guide. It's the American Society of Civil Engineers, ASCE, Manual of Practice number 92. Most folks just call it MOP 92.
hmm The industry standard,
Yeah,
basically.
and we're looking at the latest version, the third edition. Came out December 21st, 2022. It's a serious update, and it makes some pretty complex engineering stuff, understandable and frankly relevant for anyone interested in how our cities work underneath.
Yeah, it's a valuable resource. And, the backstory of MOP 92 is interesting, too. The whole idea for it actually started way back in 1991.
Oh, really?
Yeah, at an ASCE pipeline infrastructure meeting. There was just this broad agreement, a consensus that, hey, we really need a dedicated manual just for manholes,
Mhm.
inspection, rehab, management, the whole nine yards.
So it came from a real need then.
Absolutely.
Yeah.
And it was a big team effort. ACE's committee worked with NASCO, that's the National Association of Sewer Service Companies, their manhole rehab committee. It shows how important this was across the industry.
That collaboration makes sense. Now, MOP 92's third edition, it's huge. 9 chapters covering everything from safety to quality control. But for this deep dive, we're going to zero in on Chapter 5, Manhole Rehabilitation Methods.
Good choice. That's where a lot of the practical hands-on solutions are detailed.
That's where it gets really interesting, I think. So let's start at the beginning. Why do manholes even need rehabilitation? What typically goes wrong down there?
That's the fundamental question, isn't it? People often think they're just indestructible concrete rings,
Mm-hmm.
but they face a lot. You got actual structural deficiencies,
Mm-hmm.
physical damage, cracks, bits missing. Then there's just general maintenance, wear and tear over decades. But a really big one is infiltration and inflow, I&I.
I, right. Heard that term.
Yeah. So inflow is surface water getting in rain basically through covers, frames, the chimney section near the top.
Hmm.
Infiltration is groundwater seeping in, maybe through joints between the concrete sections or cracks.
Ah, okay. So water from above and below.
Exactly. And finally, there's the need to prevent future corrosion. Sanitary sewers especially have gases, like hydrogen sulfide. They can just eat away at concrete and metal over time.
Wow. So it's under attack from all sides. What's the big deal about I&I, though? A little extra water?
Well, it's not a little. Often, leaking manholes are a major contributor to SSO's sanitary sewer overflows. That's when the system gets overloaded and sewage ends up where it shouldn't. Big environmental issue.
Aches. Okay.
And it leads to treating water that isn't sewage. You're spending money and energy cleaning rainwater or groundwater. Plus, think about those chimney issues. Ground movement, traffic vibrations, freeze-thaw cycles.
Right.
That can let soil wash into the manhole from around the frame. That causes the pavement above to settle, and you see those circular cracks around the manhole cover on the street.
Ah, I have seen those. So that's what causes them. It's not just a pothole.
Nope, it's a sign of problems below. So, yeah, these aren't minor issues. They impact public health, the environment, and city budgets. Big time.
Okay. It's clear they need fixing. So where do you start? MOP 92 must lay out some options. Does it start simple?
It does, yeah. Chapter 5 breaks it down logically. For simpler inflow problems, there are fixes that don't need super specialized crews or gear. Think about the manhole covers and frames,
Like just replacing them?
sometimes. Or simpler things like plugging the vent holes or pick holes if they're letting water in. Using watertight covers is an option. If the seal is damaged, maybe a bitumastic sealant can fix it, or just replacing a rubber gasket.
Okay.
And in areas prone to flooding, you might see manhole dishes or inserts placed just under the cover. They catch any water that seeps past the main seal.
Huh, interesting. Little internal gutters.
Sort of, yeah. And then for the chimney and wall joint seals, remember, the chimney is that top section right under the frame.
Got it.
Ground movement, traffic.
Yeah.
They can break the seal between the frame and the chimney. So you can use things like mechanical seals that expand, flexible epoxy or urethane sealants, even master rubber laminates or small cured-in-place liners,
Yeah.
just for that joint.
Lots of options just for that top bit.
Definitely. And for leaky joints between the main precast wall sections, maybe from old worn-out gaskets, mechanical seals again, or those flexible epoxyurethane sealants. But you have to stop any active leaks first, otherwise the sealant won't bond properly.
Right, makes sense. You can't glue something wet. So those handle the more obvious entry points. But what about, leaks coming through the structure itself, cracks, voids behind the wall?
Now you're getting into the more, let's say, invasive techniques. And a really important one is injection grouting.
Okay, tell me about that. Sounds serious.
It can be. It's mainly for stopping infiltration water seeping in, and also for stabilizing voids, like washed out soil,
Mm.
behind the manhole wall. Crucially, it's often done before you put on a coating or liner. You seal it from the outside first.
Ah, okay, prep work.
Critical prep work. And getting grouting right depends on a bunch of things. The soil type, how wet it is, where you inject the grout, how fast the grout sets its gel time, you need containment, the right grout.
Mm.
Oh, and the cruise experience is huge, plus quality control.
Sounds like part science, part art.
It really is. And there are different kinds of grout. You've got acrylic gels. They're super thin, can penetrate fine soils. You can control the set time. They don't expand much, but create this gel soil barrier outside.
Yeah.
Great for what's called curtain grouting.
Curtain grouting.
Yeah, imagine creating an impermeable curtain around the manhole in the soil.
That.
Then there are urethane gels. They react with water, good for water barriers, soil stabilization. Hydrophobic urethane foams. These are interesting. They need very little water to react, they handle wedge recycles well, and they expand a lot. Great for filling bigger voids.
Like packing peanuts, but chemical.
Huh, sort of. And then hydrophilic urethane foams. These need moisture to react, come in different thicknesses. Good for sealing active leaks and cracks, joints around pipes coming into the manhole.
Okay, so lots of chemical tools in the toolbox. How do they actually apply it? You mentioned curtain grouting.
Right, so for curtain grouting, they literally drill holes through the manhole wall in a specific pattern. Insert packers like plugs with tubes and pump the grout outside the structure, usually bottom to top, rotating around. It creates that external seal we talked about.
Wow. Okay, injecting outwards.
Exactly. Then there's a technique called EGP expanded gasket placement. They take a foam backer rod soaked in resin, or even just dry oakum sometimes, and stuff it into a leaking joint or crack. The groundwater makes it react and swell, forming a flexible, watertight gasket right in the leak path. Pretty neat for joints or around pipes.
That is clever, using the leak against itself.
Kinda, yeah. For actively leaking horizontal joints between the precast sections, they'll do horizontal joint injection, usually with flexible urethane grouts. And for cracks running up and down, vertical crack injection. Fill the crack, create a flexible seal. Thinner grout for tight cracks, thicker for wider ones.
Man, the precision involved is amazing, just targeting these tiny leaks with specific chemicals. But what if the problem isn't just leaks? What if the manhole itself is corroded or structurally unsound?
Right. Grouting stops leaks, but it doesn't usually add significant structure back or protect against future corrosion. That's where coatings and liners come in. This is another major category in Chapter 5.
Okay, coatings and liners, what's the difference?
Good question. Think of coatings as a protective layer, a barrier, usually polymeric spray or trowel materials, epoxy, polyurethane, polyurea. They stop water, resist corrosion, like a thick, heavy-duty paint job almost.
Gotcha.
Liners, on the other hand, are typically thicker and are meant to restore the surface and add structural integrity back to the manhole. This includes things like rigid polymers, special cements, cementitious liners, geopolymers, and also cured-in-place manhole liners, CIPM.
Okay, so liners are more heavy-duty, potentially structural.
Generally, yes. And then you have composite systems, where you might use both. Maybe a cement liner to rebuild the structure, topped with a polymer coating for chemical resistance.
Combining the best of both worlds.
Exactly. But choosing the right approach. Coating, liner, composite, it totally depends on the specific manhole. How bad is the damage? Is it structural? Is there corrosion? How much infiltration? Even practical things like how easy is it to get access? How long can it be out of service?
Lots to consider.
Huge amount.
Yeah.
And one thing is absolutely non-negotiable for all of these systems. Surface preparation.
Ah, we talked about prep for grouting sealants. Same idea here.
Even more critical, I'd say. It's the foundation for the entire repair. If the surface isn't prepared right, the coating or liner will fail, period.
Okay, so what does good prep involve? More than just hosing it down.
Oh yeah. We're talking meeting strict industry standards, like from NACE and ASTM. It means thorough cleaning, decontamination, especially in sewer manholes, creating the right surface texture or profile so the material can grip, stopping all active infiltration, diverting the flow through the manhole temporarily, patching holes, resurfacing rough areas.
Wow.
Common methods are high-pressure water cleaning, sometimes over 5,000 psi, or even abrasive blasting, like sandblasting, to get a perfectly clean, sound surface.
That sounds intense. So, assuming the prep is perfect, what are the main types of coatings and liners? You mentioned cementitious.
Right. Cementitious liners, these are special mortar mixes, much stronger and more chemically resistant than regular concrete. They can stop infiltration, provide full structural rehab, and protect against corrosion, sometimes using special cements or adding a polymer top coat. They can be applied by hand trowel, sprayed on, or spin cast for uniform layering.
Gin cast, like
Eh,
pottery.
Huh. Sort of, yeah. A spinning head throws the cement onto the walls centrifugally, creates a nice even layer. Then there's formed in place, or FIP, concrete. This is pretty cool. It's trenchless. They put forms inside the manhole and pump concrete behind them, creating a whole new, usually 3-inch thick concrete wall inside the old one. Fills voids, replaces missing bricks. It's basically a brand new structural
A
manhole,
manhole within a manhole.
essentially. And sometimes they even embed a plastic sheet liner in it for extra corrosion protection. Then you have the broad category of polymer coatings and liners, epoxies, polyurethanes, polyureas.
Okay.
Epoxies are usually rigid, they add structural strength, have excellent corrosion resistance, and many are formulated to tolerate a bit of dampness on the surface. Polyurethanes can be flexible elastomeric, which is good if there might be movement, or they can be rigid. They set up really fast, but are generally less tolerant of moisture during application than epoxies.
And polyurethane.
Polyureas offer amazing flexibility, high elongation, they can stretch a lot, but they are very sensitive to moisture during application. The surface has to be bone dry. You also see hybrid systems blending these polymers. And thickness is key here. You need enough material to do the job. MOP 92 often recommends minimums, like 80 mils for smooth surfaces, maybe 125 mils for rougher ones. That's like less than 1/8 of an inch, but it has to be precise.
Tiny margins for error.
Absolutely. Finally, there's cured-in-place manhole liners, CIPM. Think of a custom-made felt or fiberglass bag saturated with a thermosetting resin.
Like CIPP for pipes, but for manholes?
Exactly the same principle. It's inserted into the manhole, inflated, and then cured, usually with steam. It forms a new, structural, jointless liner inside the old manhole. Great for structural rehab where digging it up isn't feasible. But again, surface prep is vital. You have to fill voids behind it, or water can still get trapped.
It's fascinating how you can combine these, like you said, a cement base with a polymer top coat. That seems incredibly versatile, like a truly custom fix. Does mixing materials like that cause any specific issues engineers need to watch out for?
That's a sharp question. Yes, it does add complexity. You absolutely have to ensure the materials are compatible, that they'll bond well together. And things like different rates of thermal expansion between layers can be an issue if not managed properly, could lead to delamination down the road.
Ah, okay.
But yeah, when engineered correctly, these composite systems let you tailor the solution precisely. You can address the structural issues with one material and the corrosion or abrasion issues with another. It gives engineers a massive range of options to design the best fix for that specific manhole's problems, both now and for the long haul.
Okay, so you've got grouts, coatings, liners, composites, an amazing toolbox. But how does an engineer or a city utility manager actually choose? With all this complexity, how do they land on the right solution for manhole #123 on Elm Street? That aha moment?
Right. It seems daunting, but it gets clearer once you've properly assessed the manhole and identified the specific need. Is it just inflow, minor leaks, major structural cracks, corrosion? MOP 92 really helps here with the concept of a decision matrix.
A matrix, like a flowchart.
Kinda, yeah. It essentially links the type and severity of the defect, often based on inspection ratings, directly to appropriate corrective actions or rehab methods. It helps standardize the decision-making.
Can you give an example?
Sure. So let's say the inspection finds what's rated as a low defect, maybe just a minor inflow around the cover or a single weeping crack that's not structural. The matrix might point you to simple fixes. Maybe patch with hydraulic cement, install one of those manhole dishes we talked about, or maybe just seal the crack with a flexible sealant. Relatively quick, low-cost fixes.
Okay, simple problem, simple solution.
Right. Now move up to moderate defects. Maybe you've got several missing bricks, some surface spalling from corrosion, but the wall is still basically sound, maybe multiple leaking joints. The matrix might suggest more involved steps, maybe resurfacing with a high-strength cementitious mortar, perhaps preparing the surface for a liner, or applying a corrosion-resistant coating.
More involved, addressing more significant issues.
Exactly. And then for severe issues, sections of the wall are actually missing, maybe rebar is exposed and corroding, significant structural cracking, deformation. The matrix is going to point towards full depth of rehabilitation. That means a structural solution, a fixed cementitious liner, maybe a FIP concrete, a structural polymer liner, or a CIPM liner. Or in the worst cases, it might even indicate that removal and replacement is the most cost-effective option.
Wow. So it really guides you from a quick patch to a complete rebuild based on the diagnosis?
Precisely. It takes the guesswork out. This structured approach helps manage these complex assets effectively, ensuring you're using the right technology for the problem and getting the most durability for the investment. It really optimizes how you spend those precious infrastructure dollars for the long term.
That was, wow, truly a deep dive. We went way down the rabbit hole, or rather, the manhole, from just spotting a leak to understanding chemical grouting, advanced polymers, structural liners. It's incredible engineering.
It really is. And connecting it back, MOP 92 and all these methods we talked about, they aren't just about plugging holes in a pipe access. They're fundamental to extending the life of infrastructure that's absolutely critical.
Right.
They prevent environmental hazards like those sewer overflows. They make our treatment systems more efficient, saving taxpayer money. It all directly impacts public health, the environment, and, yeah, our wallets.
Yeah. It definitely gives you a whole new appreciation for that simple-looking metal circle in the street. It's a really powerful reminder, I think, that even the most, mundane parts of our city have these incredible layers of complexity and innovation hidden away. I honestly had no idea how much goes into just keeping a manhole functional. It's
It
eye-opening.
all happens beneath our feet.
So what's the takeaway for you listening? Maybe next time you walk over a manhole cover, just take a second. Consider that hidden world, the meticulous engineering, the constant battle against decay and infiltration happening right there, and maybe wonder what other surprising complexities are hidden within the infrastructure we rely on every single day.